Quality metrics in software development are quantitative measures used to assess the quality of software products and processes. They provide objective evidence of how well a software system meets its requirements, satisfies user expectations, and maintains performance standards. These metrics help teams identify defects, inefficiencies, and areas for improvement, enabling data-driven decisions throughout the development lifecycle. Quality metrics are crucial because they give insight into the reliability, maintainability, and performance of software. Without measurable indicators, teams often rely on subjective judgment, which can lead to inconsistent quality. Metrics allow stakeholders to track progress, compare releases, and validate whether the software meets predefined quality standards. Quality metrics are often divided into three main categories: product metrics, process metrics, and project metrics. Product metrics focus on the attributes of the software itself, such as defect density or code complexity. Process metrics evaluate the efficiency and effectiveness of the development process, like the time taken to resolve issues. Project metrics measure aspects such as schedule adherence and resource utilization. Defect density is one of the most widely used product quality metrics. It measures the number of defects identified per unit of code, such as per 1,000 lines of code, or KLOC. Lower defect density generally indicates higher quality. This metric helps teams prioritize testing efforts and monitor the effectiveness of quality assurance practices. Code coverage measures the percentage of source code executed during testing. High coverage suggests that most parts of the software are tested, reducing the likelihood of undetected bugs. Tools like unit testing frameworks or automated testing suites provide data on which functions or branches of the code have been exercised during tests. Mean time to failure is a reliability metric indicating the average time the software operates without failure. Higher MTTF reflects more stable and reliable software. Monitoring MTTF helps development teams identify components that are prone to failure and improve system robustness. Mean time to repair measures the average time it takes to fix a defect or restore functionality after a failure. A low MTTR indicates that issues are resolved quickly, minimizing disruption to users. MTTR is critical in both development and operations teams, especially in environments with continuous deployment or high availability requirements. This metric tracks the number of defects reported by end users after release. It actually provides insight into the real-world quality of the software. If you see high numbers of customer-reported defects, it may indicate insufficient testing or maybe even a misalignment with user expectations, which should prompt process improvements or additional validation. Technical debt refers to the implied cost of future refactoring due to shortcuts or suboptimal code choices made during development. Metrics like cyclomatic complexity, code duplication, and maintainability index are used to quantify technical debt. Monitoring these helps teams balance delivery speed with long-term maintainability and stability. Beyond just product-focused metrics, process and delivery metrics measure aspects like code review effectiveness, defect resolution time, build success rates, and deployment frequency. These indicators reveal the health of development processes and help teams optimize workflows to consistently deliver high-quality software. In summary, quality metrics are essential tools for software development teams to objectively measure software quality, track improvements, and make informed decisions. By combining product, process, and project metrics, organizations can ensure their software is reliable, maintainable, and aligned with user expectations. Regular monitoring and analysis of these metrics create a culture of continuous improvement and, ultimately, higher customer satisfaction.